It's the end of the first week in February 2025. This is Talkin' Science. Here's the science and space headlines we followed through the week. Dark energy doesn't exist, according to new evidence. Volcanoes on the dark side of the moon. China's Chang'e 6 mission says yes. And NASA's exploring two options to get Martian samples back to Earth.
21 years online. From Star Trek to science and space. And we're not stopping. This is Talkin' Science.
For the last 100 years or so, physicists believed the universe was expanding equally in all directions and used the concept of dark energy as a placeholder to help explain what they couldn't understand. That theory has always had its problems, but now a team of New Zealand physicists are challenging the status quo using improved analysis of supernovae light curves to show the universe is expanding in a more varied, lumpier way, and that the idea of dark energy isn't needed at all. The new evidence supports the timescape model of cosmic expansion, which doesn't have a need for dark energy because the differences in stretching light aren't the result of an accelerating universe, but instead a consequence of how we calibrate time and distance. The model suggests that a clock in the Milky Way would be about 35% slower than the same one at an average position in large cosmic voids, meaning billions more years would have passed in those voids. This would in turn allow more expansion of time and more expansion of space, making it seem like the expansion is getting faster when such vast empty voids grow to dominate the universe.
So you go back and you ask the basic questions that Einstein would have asked if he'd had all the data that we have, right? And so in asking those questions, there is a sort of time dilation which is different from the ordinary ones that we're used to. So we're used to thinking about bound structures, so stars, galaxies, black holes, things like that, in which the age can vary. So here on the surface of the Earth, the Earth is 4.5 years younger than it would be if you were out when the Earth formed sort of somewhere beyond the orbit of Pluto, looking at the surface of the Earth. You'd be older there. So there's no such thing as an absolute age in general relativity. The universe can have more than one age. It's just that because we've just been looking at the lumpy bits, we've only been thinking about one certain type of time dilation, whereas there's actually another type of time dilation which is possible. It's there. It's allowed by Einstein's theory. It's just no one ever explored it.
The new analysis has been published in the journal Monthly Notices of the Royal Astronomical Society Letters. Minerals on the surface of Mars could be the last remnants of an ancient sea 3.5 billion years ago, according to international researchers. The team say there are features in the southern Utopia region that could be evidence of a coastline, meaning for a short period in the planet's history, it could have had an ocean. China's Zhurong Mars rover has been analysing deposits on the surface of Mars in a low-lying plain in the planet's northern hemisphere since its landing in May 2021. Previous research has suggested that materials in this region may have originated from flooding and marine sediments, with a fine grain size more consistent with this environment than material from volcanic activity. Bo Wu and colleagues analysed data retrieved from the orbiter and by the Zhurong rover to provide estimates of the surface ages and mineral compositions of material found in southern Utopia Planitia. They identified distinct morphological features such as troughs and sediment channels consistent with a near shore zone, suggesting a possible formation event involving flooding approximately 3.68 billion years ago. In this scenario, a short-lived frozen ocean formed a coastline, with the ocean surface likely freezing and disappearing approximately 3.42 billion years ago. Volcanoes on the dark side of the moon mainly erupted about 2.8 billion years ago, according to fragments of basalt, a type of volcanic rock, in soil samples collected by China's Chang'e 6 mission. The researchers found that around 99% of the basalt fragments collected at the landing site were from around 2.8 billion years ago, but they also found a sample that dated back 4.2 billion years. implying that volcanoes were active on the far side of the moon for at least 1.4 billion years. Lunar samples returned to Earth by the Apollo, Lunar and Chang'e 5 missions have established that volcanism took place on the near side of the moon between 4 to 2 billion years ago. However, the lack of samples from the far side means it has not been possible to confirm the timing of volcanic activity for that region. Earlier this year, the Chang'e 6 mission retrieved samples from the Apollo Basin, located in the northeastern South Pole Aitken Basin, an area with the thinnest crust on the moon, providing an opportunity to study far-side volcanism. The authors suggest this represents the age of the main volcanic episode at the Chang'e 6 landing site, which they note is a surprisingly young eruption and not recognised from observations taken from samples from the near side of the moon. Io doesn't have a shallow global magma ocean beneath its surface, contrary to what was previously thought, despite the fact that it's the most volcanically active body in the solar system, according to international researchers. The team combined observations from NASA's Juno spacecraft with all available historic data to find that volcanic activity on Jupiter's second smallest moon is unlikely to be sourced from a magma ocean just below the surface. The findings may mean we need to rethink what we know about Io's interior, as well as what is understood about planetary formation and evolution. Measuring the extent of Io's tidal deformation could help to determine whether the shallow magma ocean theory is plausible. Such measurements were taken by the Juno spacecraft in 2 recent flybys, and combining these observations with historic data, Ryan Park and colleagues calculate the extent to which Io is deformed by tidal forces. The results are not consistent with what would be expected if a shallow global magma ocean was present, which suggests that Io has a mostly solid mantle, the authors report. Whether there may be some regions of magma deep inside the moon remains to be determined, they add. The findings indicate that tidal forces do not always create global magma oceans, which may have implications for our understanding of other moons, such as Enceladus or Europa. To maximise chances of successfully bringing the first Martian rock and sediment samples to Earth for the benefit of humanity, NASA has announced a new approach to its Mars Sample Return program. In September 2024, the agency accepted 11 studies from the NASA community and industry on how best to return Martian samples to Earth. A Mars Sample Return Strategic Review team was charged with assessing the studies and then recommending a primary architecture for the campaign, including associated cost and schedule estimates. During formulation, NASA will proceed with exploring and evaluating 2 distinct means of landing the payload platform on the Red Planet. The first option will leverage previously flown entry, descent and landing system designs, namely the Skycrane method demonstrated with the Curiosity and Perseverance missions. The second option will capitalise on using new commercial capabilities to deliver the lander payload to the surface. For both potential options, the mission's landed platform will carry a smaller version of the Mars Ascent vehicle, but the platform's solar panels will be replaced with a radioisotope power system that can provide electricity and heat through the dust storm season, allowing for reduced complexity. Both mission options rely on a capture, containment and return system aboard the European Space Agency's Earth Return Orbiter to capture the orbiting sample container in Mars orbit. ESA is evaluating NASA's plan. Well, that's a wrap on the first week in February 2025. I'll be back for more Talkin' Science Daily Bites in YouTube Shorts on TikTok, Facebook, Instagram and LinkedIn. Find us, like, follow and subscribe. Become a member too to get early access to our Monday deep dives. It's all part of our 2025 commitment to bringing you science and space news and views with an Aussie flair.